Hi guys, I thought I could fit both pages in one video, but I made a mistake. So, again, you can find these pages at detroitk12.org/page/10865. We're in grade 6, and now we are on page 4 of the packet, using equivalent ratios. So again, in our tools, we probably might stick to using double number lines, tables and patterns, as well as just the concept of equivalent ratios where we multiply or divide. Unit rate will probably be the next lesson. And again, you can see those images of the tools. So, again, I suggest that you have these problems done before you watch this video so that you're just checking your work and seeing how things are going. So, if you've read problem number 1, and you either highlighted, I would have highlighted that she runs miles is 24. Oh, no. Sorry. Minutes is 24 minutes for 3 miles. And you want to know how much time it would take for her to run 10 miles. So we don't know the minutes. Well, it's not a very easy equivalent ratio because 3 times something is not 10. So now we have to do one of two things. You could change that to its unit rate. So 3 does go into 24 evenly. Or you could do a double number line. So if you chose the unit rate method, you would take 24 minutes and the 3 miles, and you would divide them each by 3. So 3 divided by 3 is 1 mile, and 24 divided by 3 is 8 minutes. So this is her unit rate. She can run 1 mile in 8 minutes, which would make you get to 10 very easily. 1 times 10 is, and so 8 times 10 is 80 minutes. Bonus. Well, how do you write that in hour and minute form? 60 minutes and 80 is 1 hour. 20 minutes left over if you wanted to. But she either needs to take 80 minutes or 1 hour and 20 minutes to run 10 miles. If you wanted to do the double number line, you want to keep your minutes on top and your miles on the bottom. So 2, 3, 9. And you want to get to 10. At 3 miles, it takes her 24 minutes. If I were to double that, double to 6, would be 48 minutes. Doubling or tripling to 9 would be 72. However, I don't know how much to get to 9. So I would have still needed to kind of figure out that unit rate. So it takes 1, 2, 3. If I take 24 and divide by 3, I would have realized we were increasing by 8 for every mile. So 72 plus 8 would have given me the 80 minutes for 10 miles. So just depending if you need to see it more visually or if you can do more of the algorithm in your head. So that was a pretty hard problem because it wasn't a simple just increase. All right, the next one says that a chef is planning for a large banquet and thinks that 2 out of every 5 dinners. This is not a part to part. This is a part to whole ratio. So for problem number 2, you're comparing like the people who order soup to the total amount of dinners. So 2 out of every 5 guests will order his soup if he expects 800 guests. And I guess we could put that as the total. How much soup? Now drawing a double number line because we're jumping so big from 5 to 800 isn't very practical. So I think some multiplication might be more of the regular one. All numbers that end in 0 are divisible by 5. So I could figure out how much we're jumping. So if I went the reverse and did 5 into 800, and don't forget that you still need that last 0. A lot of times when kids are dividing and it can't go into it, they just skip it. But you still need that 0 to hold the place value. So you know you're timesing by 160. So if I were to double 160, I would know that 320 guests out of 800 would have preferred the soup. Okay? Next, Fred, this is a good one for a table because you have 2 parts and a total, and they're all important. So Fred's making a fruit salad, and he has peaches to cherries, which is 5 cups total. So peaches is 2 cups, cherries is 3 cups, and then the total amount that the fruit salad is 5. So it wants to know, the question's asking, how many would he need to make 60 cups of fruit salad total? So really, I need this 5 to jump up to 60. So I just wanted to show you how the pattern works. If I were to double it, I would double every number, okay? If I were to triple it, I would triple every number, okay? I'm going back to the timesing by 3. So if I were to get to 60, 5 goes into 60, 12 times. So that means I need to times each of these numbers by 12. 12 times 3 is 36, and 12 times 2 is 24. And the real question is just how many cups of peaches will he need? And peaches is the first column. He would need 24 cups of peaches. All right, a community center is hosting, and so last year 50 families were able to get 150 plants. Based on this ratio, how many plants? We want to get to 65. 65 families. And again, 50 doesn't easily go into 65. So you might want to, again, try to figure out the unit rate. Right? So it does look like these can be divided by each other. If I were to divide by 50, I would say one family gets 3 plants. So now, if I want to jump to 65, I would just need to times by 3. Or times by 65. So if you don't like multiplication, some of us can easily do that. Or some of us prefer to just add 65 3 times. And I bet you we still get, I would need 195 plants. So 65 family, 100, and that makes sense because 50 families, 150, a little bit more would be 195. All right, problem number 5. I think I can get in here. Problem number 5. You have 49 dogs. And you want to know 28 cats. What would it be if you had 20 cats? Again, this is not a number that easily goes in there. So I like to find the unit rate. So I just kind of look at 49 and 28. And if you get your multiplication table, you might want to try to see what 49 and 28, what row or column they line up in. And hopefully when you do that, you can see that these guys are both divisible by 7. They're multiples of 7. So that means when you have 7 dogs, you would have 4 cats. So it's not exactly a unit rate because we don't have a 1. So we're just going to call it a rate. 7 dogs to 4 cats, but we do know we can get these 20 cats to go into, the 4 to go into 20. So 4 times 5 is 20. So 7 times 5 would be 35 dogs. So when there's 20 cats, there would be 35 dogs in the shelter. And for our last problem, a wedding planner uses 72 ivy stems for 18 centerpieces. They're kind of like vases, vases. But she wants to know how many would she need if she just needed 16. So again, 18 and 16 are not very compatible. So I think trying to find a unit rate or a rate. So I look at the numbers 72 and 18. And I'm going to just try to divide it to lower it down. So they're both even numbers. I know they're divisible by 2. So 2 into 72 is 36. And 18 divided by 2 is 9. If I look at these two numbers, I know that these can both be divided by 9. And I end up with 4 ivy stems to 1 centerpiece. So this is a unit rate because I can get it down to 1. So I can take my 4 to 1 and get it to equal the 16 centerpieces. Clearly, I'm multiplying by 16. So again, I can just add 16 4 times and get 64 ivy stems. Or I can multiply and still get the same answer. I would need 64 ivy stems. And that makes sense because 16 is just a little bit less than that, and 64 is just a little less than that. So, thanks, guys. Don't forget to like, comment, and share. No, I'm joking. This is just for your math work. I'll be back tomorrow with the page 5.